is lesson 83, factoring special products. Specifically, we're going to be dealing with the perfect square trinomial and the difference of two squares. Both of these concepts were already reviewed, so should be pretty familiar to you. We reviewed the perfect square trinomial back when we were multiplying binomials in lesson 60. Now we're going to start with the finished product from lesson 60 after we multiplied the binomials. What we do when we have a trinomial and it's a perfect square trinomial, we look for a pattern. We look at the number in the back here, the constant term, the one that does not have the variable, and we ask ourselves, what number times itself is this back number? The answer to that question is 7, because 7 times 7 is 49. We then ask ourselves, if we take that 7 and multiply it times 2, will it get this middle term here? The answer is yes. This here is a perfect square trinomial. If I was to factor this perfect square trinomial, it would factor to look like this. X plus 7 to the second power. Let's take a look at another very easy example. X squared plus 12x plus 36. Here, recognizing 6 times 6 is 36, and then 6 times 2 is 12. This is a perfect square trinomial. Looking to factor this, I would put the parentheses. Everything is addition here, so I would put an addition sign between. 6 times 6 is 36, so the 6 goes there. X times x is x squared, so the x goes there, and then I put a 2 there. Now sometimes this is going to be a negative. Let's take a look at another example. X squared minus 6x plus 9. We look at the back number, which is 9. 9 is 3 times 3, or negative 3 times negative 3. Remembering that a negative times a negative is a positive. So I see this negative here and realize that it must be a negative 3 times a negative 3. Negative 3 times 2, and that's how the negative 6 came about here. So in looking to factor this one, I put an x in the front because x times x is x squared. I put a 3 in the back because 3 times 3 is 9, but instead of putting a plus sign, I would need to put a minus sign in between there. Sometimes this x squared, our leading term, is also going to have a numerical coefficient. Let's take a look at an example that has that as something going on. Here I have 16x squared minus 24x plus 9. Okay, so how do I get this 24 here? What happens here? Well, this is where I have to remember back in lesson 60 when I learned that a squared plus twice ab plus b squared. It could also be a squared minus 2ab plus b squared, where I take the back term and the front term and I multiply them times each other. Whatever they are, I multiply it times each other, and then I multiply that by 2. If I do that and get this middle term 24 here, then I have myself a perfect square trinomial. Let's take a look. Open up the parentheses. We have a negative sign here, so automatically we're going to put a negative sign here. 16. Well, 4 times 4 is 16, so a 4 goes in the front there. We have a 9 back here. 9 times 9, or excuse me, 3 times 3 is 9, so I have to put a 3 here. I have an x squared there, so an x gets written there, and I put a square. Oops, forgot that square there, sorry. Now, When I multiply these two things times each other, 4x times 3, I get 12x. When I take that and multiply it times 2, remembering up here I have to multiply it times 2, multiply them times each other, and then multiply that times 2. In doing that, this is a negative, this is a negative, this would be a negative 24x. And that's what came here, negative 24x. So the answer to the question would be yes. It is a perfect square trinomial. Factoring it would look like this, 4x minus 3 to the second power. Let's take a look at one more of that sort. Let's look at 36x squared minus 48x plus 16. In our attempt to factor this, the very first thing that we would do is factor out their common factor. The greatest common factor between all of these things is 4. So I would factor out first of all the 4. Put the 4 in the front of the parentheses. And in the parentheses, we're going to write what's left. What's left is 9x squared minus 12x plus 4. Here is my perfect square trinomial inside of here. Here I have 3 times 3. Here I have 2 times 2. My next question is when I multiply 3 times 2, I get 6, and then 6 times 2 gets 12. So what do I do from here? I put the 4 in the front, open up the parentheses, put the square back here. Since this is a negative, I go ahead and write my negative. 3 times 3 is 9, so this is 3x. 2 times 2 is 4, so that's a 2. And that's how I would factor the perfect square trinomial. Let's take a look at a difference of two squares. The difference of two squares is actually a pretty easy concept because all you really have to do is recognize the pattern again.